Welcome to our educational channel. In this video, we will learn about Apoenzyme. Before that, what is Holoenzyme? A holoenzyme consists of Apoenzyme and Coenzyme. Apoenzyme is an inactive protein and protein part of holoenzyme, while the coenzyme bind to Apoenzyme to form Holoenzyme, which is a complete and functional form of an enzyme. Coenzyme is a non-protein part of holoenzyme. This combination allows the holoenzyme to catalyze specific biochemical reactions effectively. The apoenzyme is protein part of the enzyme. It is an inactive protein on its own because it lacks the additional component needed for full functionality. The apoenzyme is heat labile and provides the structural framework and specificity for the reaction. Coenzyme. It is non-protein part of the enzyme. Coenzyme binds to the apoenzyme to activate it and form holoenzyme. The coenzyme is heat labile and low molecular weight organic molecules. They combine loosely with enzyme molecules. Most of the coenzymes are derivatives of vitamin B complex group of substances, like FAD derived from vitamin B2 and NAD plus derived from vitamin B3. Some coenzymes are not vitamin derived like ATP, CTP, and UBP. Coenzymes typically assist by transferring chemical groups, electrons, or atoms during the reaction. The specificity of the enzyme is mostly dependent on the apoenzyme but on the coenzyme. Mostly coenzymes are considered co-substrates because they bind loosely, participate in the reaction, and dissociate after being altered. But not always they are considered as co-substrates because coenzyme is tightly bound. It might be classified as prosthetic group instead, but not co-substrate, since it doesn't dissociate. Hence, coenzymes describes the molecule's identity, and co-substrates describes its functional role. The term prosthetic group is used when the non-protein moiety tightly binds with the apoenzyme. They are mostly organic and some are inorganic. Cofactors are non-protein chemical compounds or metallic ions that are required for an enzyme's activity. They assist enzymes in catalyzing reactions by facilitating the chemical processes that the enzyme alone cannot perform. Cofactors can be divided into two main categories: inorganic cofactors and organic cofactors. Organic cofactors are referred as coenzymes. These are typically metal ions such as magnesium, zinc, iron, copper, or manganese. They stabilize enzyme structure, participate in substrate binding, or assist in electron transfer. They are two types. They are metalloenzymes and metal-activated enzymes. Metalloenzymes are enzymes that incorporate one or more metal ions either in their active site or as a structural component. They tightly integrate with the apoenzyme. These metal ions are inorganic cofactors, and their presence is essential for the enzyme's activity. Without them, the enzyme is typically inactive. When the metal is bound, it becomes fully functional holoenzyme. Metal-activated enzymes are enzymes that don't inherently contain a metal ion as part of their structure but require the presence of specific metal ions in the surrounding solution to enhance or enable their catalytic activity. The metal ion isn't tightly bound as cofactor or prosthetic group. Instead, it interacts loosely or transiently with the enzyme or substrate to facilitate the reaction. If you found this video helpful, please like, share, and subscribe.